Okay.
Three, two, one. Hello, everybody. Welcome to Someli. This is gonna be the third podcast, and here I have my guest on the right. Introduce
Oh,
yourself.
I'm on the right.
Yeah, you're
Oh,
on the
there is
right.
direction.
Yes, there
Okay.
is direction.
Hi. Am I supposed to introduce myself?
Yeah. What do you like
Okay.
to do, Hakan? Like, cause you have Kimeiga, you have all these other things. You do a lot on the internet.
Oh, okay. That's true. I mean, I recently I've been telling Americans hockey, which is like my nickname,
Uh
and
huh.
they've been pronouncing it a lot more consistently than my real name, Hakan.
Mm-hmm.
But I mean, I don't know. Like you could call me either of them. Yeah,
Yeah,
I also
cool.
go by Kimeiga, Kimeiga, and I like make video games. But I'm over here in UCLA doing computer science. I don't know what else to talk about. I mean, I
Okay.
make bmaps.io. It's like a event discovery app for UCLA, a few other things.
Yeah, because what I wanted to talk about with you for this podcast
Okay.
is what it's like to be a part of computer science. Because it's grown so much more in just the past 10 years.
Oh
And,
wow.
like, for
Okay.
example, a lot of people I meet in UC Davis are coders. Some of them are throwing themselves into it right here in college. Some of them have been, like you, have
Hmm.
been doing it for years. And
Hmm.
one common thing that I've seen is that it's the homeworks are a pain.
Oh yeah. Oh yeah.
So
Oh, you
what?
want me to talk more
So
about
so
it?
what's it's like? Yeah, like so. Let's go through. Um, let's go through your time at your recent internship. Like, what's it like being a coder in an indie industry?
In the industry?
Yeah.
Okay, so I worked so I was at Symantec in the consumer business unit as so I was on the Cloud Connect team, which is the team that handles all of the transactions. Like anytime you buy anything from Symantec, like Norton Security, it'll go through some of our code and it'll like send the receipts up and down the internet and then like confirm the purchases and then like grant you tokens that acts you can use on your client to like access the service.
Mm-hmm.
So like I was a front end developer, meaning that like front end and back end are sort of two really like hand wavy terms that we use to describe the two like common places that you might work within like the infrastructure of a application. So the front end is like the user interface. So if you're working on a web app, then it'll be like HTML, CSS, and JavaScript, which is the markup, styling, and front end code, respectively. And then it'll also constitute like anything that has to happen on the client, like client side, will be front end development. And then back end development will be like, I guess it depends on what back end server you have. But at Symantec, we were doing, we had an ASP.NET core. That's like different from ASP.NET as our backend. And that's like basically C sharp stuff. That's been around for a while. I mean, like UCLA uses that for our course registration thing and for CCLE, which are like the two main things that we like use on a daily basis because it's been around for a long time. It's being pushed by Microsoft, all that stuff. So that is like backend coding, and that's where you like actually write the code that changes like server state, like it receives the request from the client and then it like does some code to actually register the transactions and do things that mutate the database, and then it'll return a payload, which is like information that is given back to the front end that tells it what to render. So like an example route would be if someone wanted to buy Norton Security Premium, they'll like go on the site and then like it'll run some of my code that will like uh handle the purchase, and then it'll go to the back end, and then the back end will like append that person to like the subscribers of Norton Security Premium, like that sort of list or something, and then it'll give a token back which can be used by that person to like log in to the app. So essentially like I was working in the front end department, which means like because Symantec is kind of a slower company, they didn't really want to make too many additions. They just wanted to speed things up because they were using like Angular JS, which is the first version of Angular, and Angular is like on version 8 right now. So they haven't updated it in like 12 years. Sorry, what?
Angular is a programming language.
Oh, Angular is a JavaScript framework. So
Ah, okay,
JavaScript
okay.
by itself is not really enough to build a web application with because it's kind of dumb. And it's not really a great language, and it's also like Yeah, it's honestly a really bad language, but it just became the lingua franca because every browser can run it.
Hmm.
There are some browsers that can run other languages, but since JavaScript is run by all browsers, including mobile browsers, like it's the one that you'll have to use to do anything in front end.
So if we
Um,
put it in very simple terms, the front end is whatever the user interacts with and sees on the website, and
yeah,
then the back end is whatever's going on behind the scenes to make all that work seamlessly.
that's right. Yeah, that's right.
Okay. And
So my job at my like at Symantec, if you wanted to know, was that I was trying to like optimize like a lot of the paths that were really common for users to use because since AngularJS is so old, like it's not really a very good framework anymore. And there were times where like users were reporting like 5 to 10 seconds from the point they like tapped on a button to when it was responding. So I just had to do a lot of optimization.
yeah, because a lot of these things on the internet, you like it to be fast and quick. Like it's really annoying when your computer's not even running at full speed. We click on the
It is,
Windows
yeah.
option and it takes like 5 seconds for the whole thing to pop up.
And from a business perspective, like generally internet, you like most people who use like internet in the like first world, like they generally expect 2 to 3 second response time, and if they don't get that, they'll like they'll just go away. So
Mm.
you can have a lot of like people who could be potential customers who you just lose to like slow interfaces or buggy interfaces.
Huh. So you got to learn a little bit of the business side of it too.
I mean, that's something I kind of knew going in because that's just like when you like read about yeah, it's common sense, and it's also like when you read about the motivation for people to optimize their front end applications, they'll like link number if they're like a company and they're doing a blog post where they're like, oh, we like increased retention by like 54% by using like slightly more optimized this and that. What they mean is like 54% of people like didn't navigate away from the website based on a certain route just because like it was more responsive than before, and they just didn't like unconsciously get fed up and just leave. And yeah, so that's why it's kind of powerful.
Yeah, actually, when working on the channel stuff, sometimes YouTube Studio is like really, really slow. And it
Hmm.
was really annoying, but I had to deal with it because there's really no other option. But I
Oh
for
yeah, if
something
you have a goal
else,
in mind, you'll pursue it, right? Yeah.
yeah. But like if it was something else, like I was just curious and it was taking forever, I would just leave. I wouldn't care. It wouldn't affect me
Right.
that much.
I mean, that's most people too, right? If you like, no, you don't have anything that you have to get done. If you're just curious, and that's like your reason why you're like looking at something, and it's like not loading in 5 seconds. Like most people just leave and just continue scrolling or doing whatever they're doing. I don't know.
Yeah, it's honestly a little bit how like our attention spans on the internet are so short. Like
Hmm.
everything happens for like everything is like important for like the day, and then afterwards, no one really thinks about it too much. The
Hmm.
news and ideas keep passing through relatively quickly.
Yeah, it's actually really sad. We're sort of like building a future where we don't have to worry about where we don't have to like retain attention spans longer than a few seconds, and it's really bad, but it's also like it presents a bunch of interesting engineering problems, which is like I guess why we do it. But yeah, it's really bad in general.
That's why I kind of doing this podcast, and I like ideas like this because it's instead of just you have your 5 minute sound bite or 2 minute or whatever or a little vine. It's long form discussion about ideas, and we can sit down and discuss them. Because like
Sure, yeah.
you can't get too much out in just a few little seconds someone pays attention. But if you can get people to sit down and listen to a whole conversation, then you can get those ideas rolling.
Yeah, I got you. I feel.
Um, I was talking to some other fellow students at UC Davis about whether or not we would let our kids have phones, like at least from an early age. And
Yeah.
I got to, yeah, everyone agreed in that little class discussion that we wouldn't want to give our kids phones from an early age, and we were also arguing like when would be apt. I think the agreement was somewhere within like late middle school or high school,
Sorry.
late middle school to high school, like early high school,
Hmm.
because when you have like the little kids that you see them all the time, like they're always on their phones and not really paying
Yeah.
attention, and but then the
Yeah.
contrast, you also have the parents on their phones not paying attention to the kid.
Yeah.
So I would rather not give my kid like that much technology. Like I'm debating
Mhm.
what level I would want to integrate him with technology because it is important, but not the end all
Mhm.
be all. And then
Mhm.
how much you'd want to be able to actually spend physical time with him and have these discussions and let him build out that attention span.
Mhm. Yeah, I agree. I mean, especially at a really young age when the child is like, it's like a very formative age for like 0 to 3 or 4 years is very formative for when children learn how to interact with the world around them. And there are like videos of like children who grew up with iPads who try swiping on books and like scrolling on books and stuff like that.
Huh.
And when it doesn't work, they just like kind of push it away and go back to the iPad. And it's really bad. I mean, like things like that are not what you want like a child at a formative age to learn to use because then they're just like when normal things in the world don't respond in a very like responsive scrolly manner that UI on a phone might, they just will kind of push it aside, and then that will just mean that they'll have a lot harder time like reading books and like interacting with things that aren't super straightforward that require some physical dexterity in the future, and
Because
it's very
it
bad.
takes
Yeah,
effort. I have to
yeah, or
move my
anything that takes
hand.
or to turn a page. Really, what it is like they like are kind of developing neural pathways for uh, very short bits of information that are easily like scrolled and pushed aside, but like all in one kind of cohesive unit where that unit is the phone, right? Like you don't have to turn the phone over and look at the other side. You don't have to like
Mm-mm.
press buttons on the phone so much as you just like gesture around, and like everything is sort of localized on that screen. Whereas a book, like if you want to read the next page, you have to like lift the current page across the book and then place it down on the other side and then use your eyes and look at the next like passage. It's not exactly like
Oh yeah.
you swipe like a Kindle on the book and then it just presents you with the next passage.
So then some people would argue that it's not that hard to just lift a page and keep going, but when that's all you know and that's all you've been integrated in, like the seamless flow of what you can do on a smartphone or a laptop, it makes it much more difficult to if like that's all you've done at an early age. It's much more difficult to build these other neural pathways and these other behaviors
Right, right.
afterwards. Like there are like adults that have things from their childhood that really do stick with them and they don't really realize it because that's how important those years are to us.
Hmm.
And I notice those in myself, and I'm sure you have examples of those too.
Yeah, I mean, I think so. Yeah, it's usually the parents' fault. I mean, like if we want to keep talking about this, it's like parents who don't understand like basic psychology, who think that like, oh, my kid is annoying, let me just give them a phone and they'll shut up. And then
Actually,
it's like, yeah.
actually, Marks and I were gonna get into that subject on the first podcast, but that was at the very end about like parents that don't set limits on their children. That it's very dangerous to have a kid that doesn't recognize the importance of no. Once they enter the real world or have to socialize with other people and things aren't handed to them as easily, they don't have to work for anything. Well, they don't know to work for anything because that's everything they've been given made easy for them. It's much more
Right.
difficult for them to integrate with other kids and just people in general, and will affect them
Mm,
and alienate them as they grow up.
that is true. That is
Jordan
true.
Peterson talks about a lot of stuff like that. He a lot in a lot of his discussions he mentions the importance of the early ages, especially from 0 to 4, about socializing your
Mm,
kids and making sure that they're like as a parent you want them to be a kid that other kids want to hang out with. Like
right.
you did a good job if on the playground all the kids are fighting to be friends with your kid.
Right. 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 Right.
Okay, so next thing I want to ask: is there any
Okay.
like unifying thing between a lot of the people you meet, like who go into coding? Like, is there any type of person?
In computer science.
Yeah, yeah.
Well, they're all introverts. I mean, not all of them. Obviously, I'm not, but like a lot of them are.
Hmm.
Um, a lot of them don't. I mean, it's true. It's true. I mean, you're an ambivert, so like I wouldn't call you an introvert per se, but like I think a lot of people who generally like stay at home and just like do things by themselves are introverted. And then when you stay at home and do things by yourself on your computer, like naturally, one of the things you might consider is coding, right?
Mhm.
Like it's a very easy, thing to like to go to, I guess.
So how
I
does
don't know.
one get into it? Like
I just want to get
where does
into
someone
it.
start off if they want to go into coding?
You know what's really funny? Like my roommate who I'm talking to right now was giving advice like along the same lines to one of our friends' brothers who's like going into college now, about like how to get into coding, like what do you want to do? So do you want me to just put him on?
Sure, if he's okay with it.
All right, here we go.
Okay, cool, and we're back.
And we're back.
Yeah. What's up?
So
This is my friend. This is my friend Tian, by the way. Tian meets Steven. Steven's one of my childhood friends.
Oh, hello, Steve.
Probably like oldest childhood friend. Like
Oldest
actually,
as in longest or oldest
I think
as in
Ben's a little bit
physically
older.
oldest?
yeah, Ben is a little bit before your time, but
Just a little
yeah,
bit.
like just a little bit.
Anyway, so what I just asked Hakan is, how does someone get into coding? Like, where does someone start, and when do people start too? Like, when is a
Okay,
good time to start?
Is this for a purpose of yourself, or are you trying to
No,
give a
just
talk?
having a
or-
discussion, just about
Just having a
people in
discussion?
general. Yeah.
All right. Well, I suppose the majority of people that I know that got into coding, it's one of a couple of reasons. The most obvious and one that see most frequently, honestly, is just money. People see it's easy.
Yeah, it's hella bandwagony.
Yeah. It's just easy money. You know, people think, oh, I can make lots of money if I do coding. I don't need to go to grad school. I don't need to do all the other stuff. It's the most lucrative of all the engineering. So I'm gonna go into coding. It's also high tech and seems moderately interesting.
It's also one of the easiest for international engineers.
Yeah.
Like considering like, in other engineering fields you might have to be hired by government, but if you're in coding, like you may not have to, right?
Yeah.
When I say coding, by the way, I mean like computer science. Like I'm just trying to use the same terminology that you would use, but like coding by itself is not something that like only people in computer science do. Like there's a lot of people who also do like
Coding
yeah, like a lot of
research.
people who do math or MATLAB or any kind of research where they have to learn Python, sort of like a little bit more junior programming languages. Those people also need to know how to code, but like they're not really going into computer science per se.
Mm.
Like when we're talking about coding, we're probably talking about majority computer science specific like stuff.
All right. So, if someone were to start, which programming language would be a good starting point? Like,
Python.
What are you looking to do? Are you looking to build fundamentals? Are you looking to be able to get something out nice and quickly and easily? It depends.
let's say
I would say Python, like without just to get fundamentals. If you know like literally nothing, like Python's sort of like the king of the amateur programming languages, just because of its lack of syntactical like qualms, really.
Oh yeah,
what were you gonna
Python
say?
is like the simplest one to kind of understand, just by reading.
I wouldn't
through.
put it that as far as the simplest to understand. And Python has its own.
Well,
issues
because
with
of
idiosyncrasies that make
object
it
pointers, you like the way it only does what's it called?
annoying. Namespacing.
Namespacing?
is a pain in the ass in Python.
Oh, but that's only if you have more than one like file. You know, if you're working at one file at a time, like you're just trying to learn how to do a for loop, like most likely you wouldn't have to deal with namespacing.
Well, but Python overall is probably the easiest in terms of syntax, but it does leave a couple more important topics like memory management out, which is
Okay.
where things like C comes in. If
That's
you're
true.
looking at it,
So,
and that's if it's
so what languages are the best to learn to go into industry? Like,
That's highly dependent though on
I'd
where
say
you want to go.
Universally,
Probably
Python as
JavaScript.
well as C and JavaScript. Those three.
JavaScript, just because like if you want to do anything in front end, you need JavaScript, just because every like as I said before, every browser can run JavaScript, which might change in the near future depending on like how the like web consortium figures out what they want, because there have been like a lot of requests to have non-JavaScript languages like being
Everyone hates
supported in browsers.
JavaScript.
Say what?
Because everyone hates JavaScript.
Yeah, because everyone hates JavaScript. I mean, okay, so to kind of, I know I alluded to that earlier, but to give some like background for why that is, JavaScript started out as like a very weird like Frankenstein scripting language that was only meant to just like do a few things in the very beginning, and then people figured out that you could use it in some like weird ways to create web interfaces, and then everyone, business people were like, oh, that's really good, let's do that. And then so everyone started doing it, and then like the web consortium was like, oh shit, like this is not like a, this language like can add like numbers, it's not really meant to do anything of that scale. And so like it became acquired by ECMA, which is like the European like Standards Association, and they called it ECMAScript. And ECMA has been like updating it every 4 years or so with like more and more like complicated things just to support all of the different like expansive projects that people are creating with it. Like first it was a prototype based language, meaning that like every object has an object prototype, which is the only way that you could do like polymorphism. But now there's like classes and stuff, which is like a lot more analogous to general object orienting programming, which was what was started like by like C# and like the big Microsoft languages from before. So now it's in a better position to do all of the heavy lifting that people like expect it to do. But like it's still a language based on a lot of like weird quirks that they can't get rid of because they would break legacy code if they did. That's like a common problem in computer science. Like you can't really move forward with a language that's been used like for so many years, because if you make a change that's called a breaking change, where you like modify the language's spec to change it to something more logical, but everybody has been writing code in the illogical way from before, you don't want to break like everyone's code. This is a big problem with Java too. Like Java's been around for so long, and like all the parking meters are written in Java, the vending machines, all these like sort of appliances. And if Java was to make a big breaking change with the next update, you like update your parking meter, and then like all of LA like stops collecting parking fees because like it all breaks and some shit. Stuff like this is like why CS is such a volatile like environment in updating programming languages. So that's why everyone hates JavaScript.
So it'd be a huge undertaking to update everything at once if you wanted to make the program smoother.
Or that's why their entire job is dedicated to just updating code.
Yeah, there are people out there who literally their job is to like update all the dependencies in a project to the latest versions without breaking the project. It really be like that sometimes.
And they're very high level engineers because it's very, very difficult to do it, especially with very, very old code.
Mm-hmm.
Wow. Most people will probably never realize stuff like that and how much runs on these programming.
Yeah, most people won't, and that's actually like great, because if you don't realize it, that means it's doing its job. If you realize it, right, that means like something's wrong. Yeah, because it crashed, or it lost all your files, or like I said, the parking meter stopped collecting money, like something bad happened. Or like recently, right, the Iowa caucus didn't get its election results, or not the election results, but yeah, because that one company called Shadow Inc., they like made they had like a failure in their data collection or something, and so like the Democratic Party is now in a bad spot, and like all this stuff is like because of just the volatility of computer science.
Mm-hmm. That was pretty shocking in itself.
And did you see that meme format of Nancy Pelosi ripping up a piece of paper behind Donald Trump? Like, where did that come from?
Okay, yeah, so we had the State of the Union address on Tuesday? I don't remember.
Yeah.
Anyways, he did a great speech. I had to give it to him. He did a good speech. He talked about a lot of good American stories and the things that are happening in the country that are good for the country. And like for example, the lowest unemployment rate we've seen in years, and how the economy is at the best it's ever been before in American history, and the list goes on and on. The whole speech, there's one part where he reunites a family. He talks about the Tuskegee, one of the Tuskegee Airmen who was there, and he elevated him to the position of Brigadier General. Rush Limbaugh, who was diagnosed with I think it's stage 4 lung cancer. He was awarded the presidential, I think it was the Medal of Freedom, the highest honor a civilian can get. And all these really feel-good things. And then the Democrats throughout the whole thing were sitting down and like not applauding stuff like the Tuskegee Airmen or the family reunion, and they eventually started walking out, and they were on their phones. And then at the very end, Nancy Pelosi stood up after Trump finished and started ripping up the speech, visibly. and
Mhm.
now she's getting in hot water for it. There were a bunch of calls into C-SPAN of Democrats who saw that as disgusting and will no longer vote Democrat because of it.
That's a little extreme, but okay.
I mean, that is a pretty bad move. Not gonna lie.
Well, let me read the speech. Like I'm gonna forego judgment until I see what this was.
No, yeah, go ahead and do that. But like, just my point is all that
Just
They
conte-
said
just the
lowest
context
unemployment
of-
rate, and then they're sitting down. Like that's not a good thing.
Yeah, it's just the context itself. It doesn't matter what exactly it was because most people won't know what exactly happened. They'll just hear context.
Well, right. I mean, I just meant to say, like, from an educated perspective, like,
okay.
it's important for me to know, like, what really was on it, because, like, I can see this being something that could be really construed by hearsay, just because it became such a meme in such a few days.
No, it did become so. There are memes of her ripping up the Constitution, ripping up the articles of impeachment. There's a lot of stuff like that. There's one.
I've just been seeing it used as a format, like where like people put text over her and over Trump and over the speech. But yeah, go on.
There's one meme that I saw, which I thought was pretty funny. It showed, you know what horses, I think it's horse, where like, people stand at certain points and try to shoot the basketball and make it in. They have like 3 basketballs at each point or whatever. It's like
the horse, the game.
Yeah, the game.
Oh yeah.
So
Okay.
There's this guy, and he's there's text on him that's floating on him that says the Democratic Party, and then he picks up a basketball and he shoots, and on the basketball it shows Russian collusion, and then it misses the basket. Then he picks up another one and it says impeachment. He shoots and it misses the basket. Another one is Nancy Pelosi ripping the State of the Union address, and it like misses the basket and all this kind of stuff. And I thought that was pretty funny. I thought that was like pretty hilarious.
Yeah, that's true. I did not see that.
Related to this.
Okay.
So, one thing I learned about recently is deep fakes. And,
Okay.
Okay.
I just was curious what would you have to do? Like, what kind of program would you have to build that could map someone else's face onto someone else, like very convincingly? Copying expressions.
Oh, how to make a deepfake?
Yeah.
Well, first of all, you need 1 million samples of said person's face, so that's why you see it of movie stars.
Mm-hmm.
Because essentially, what the computer will do, from what I've gathered about deepfakes, is essentially it tracks markers on the face, right? And then based on every single essentially frame that your face is talking, every single expression you have, it looks at the marker and goes to that massive database of that person's face and looks for matching markers, and then like imports the face.
So it sounds a little bit like neural networks, something that I've been hearing from my roommates recently.
Yeah, this is an application of machine learning for sure. As Tian said, like machine learning is generally most useful when you have a very large amount of data, and so deepfakes are often made on actors and actresses because there's a large amount of data, like lots of pictures of, lots of still frames of their face in various movies doing various actions, being well lit, right? Like the lighting is always good in those movies, enough to read their expression, and then, being mapped onto other people's faces. Like I guess the actual mapping part would be like there would have to be an internal representation of like the topography of a normal face, and they would like map certain features onto the base layer of the video, and then just identify those same features in the actors and actresses' face, and like contort the image such that it was like each feature was on top of where it was supposed to be, and like the perspective was correct.
Is it easy for people to do, or do you need a lot of coding knowledge, specifically with neural networks and machine learning, to be able to?
I mean, a lot of
it's not easy for
there are libraries out there. So it's annoying, but it's not impossible.
I don't know how many libraries are for making your own deepfakes. I'm sure there's something out there for it, but I think like in general, since machine learning has become such a big thing, like the biggest thing that you'll run into is just like not doing what's called feature extraction properly. That's like what we were talking about earlier when you like identify the like eyes, nose, mouth, and other features of your input data. Eyes, nose, mouth of the base layer of the video as well. That's called feature extraction, and that's generally the hardest part of machine learning because the actual machine learning itself is usually like done in libraries that have been written for you already. So like a common example would be like if you use SciPy or scikit-learn, those are like machine learning libraries that are written in Python that you can call with just like a few method calls that aren't like, you don't have to implement the neural network yourself. You don't have to implement any of the gradient descent yourself. All of the stochastic gradient descent, all of it is written for you. But like you do need to supply it with like properly cleaned like data in a format that it can like make actionable like decisions on. And then
properly cleaned data.
So an example would be if you wanted to write a machine learning algorithm that like makes some decision, let's say chess. Like let's say you want a machine learning algorithm that can play chess, even though you can actually write a classical AI to play chess because it isn't such a very large state space. Really quickly, machine learning grew out of the inability of classical AI to deal with like increasingly complex systems. Classical AI is just like AI that uses like if statements to determine what to do. Like
Decision tree.
yeah, like a decision tree. Yeah, you've probably seen those or even like use them in everyday life, right?
A little bit in Scratch.
Oh yeah, that's true. In Scratch, in that Someli event, Game On, we made some of that. And then the most the most complicated that classical AI can get is like stuff like Prolog, like languages that are able to like make logical analysis on truth statements and like things like finite state machines. But even that, which is like fairly complicated, it still can't like simulate like a rational actor in a fairly complex system. So a good example would be like chess is a game that you can write a classical AI for because there's not that many states in the game and there's not too many different strategies that it is impossible to do. But a game where you can't write a classical AI to play is called Go. Yeah, have you heard of Go before?
Nope, I've never heard of Go.
So Go is like it's like a really old Chinese game with like a 11 by 11 grid, and you have like a large set of like black stones and white stones, and like two opponents like take turns placing a stone on a grid intersection. And there's only you've seen that?
Yeah.
It's also in like anime sometimes.
And go on with your explanation for everyone else.
Oh yeah. So that game is like, since you have 11 by 11 game board, and there's like a relative to the size of the game board, there's like an infinite number of black and white stones. You have like 11 times 11 different spots, and like one or two different, like either a black or a white stone or nothing could be there. So you have 3 to the 11 times 11 different states that the game could be in at any given point, which is like an order of magnitude larger than chess, right? So Go is like a game that like has been notoriously hard to write AI for until recently, when AlphaGo was created by engineers at I think either Google or OpenAI, and it used machine learning. So yeah, that's like kind of why machine learning sort of grew out of the need to like natural language processing is another thing that people tried to write classical AI to do, but was really difficult because like natural language is so irregular, like especially English, that it just makes it really hard to write like good classical AI. So again, like people use machine learning for that.
Okay. Have you made anything with machine learning yet, or do you want to one day?
Do I want to one day?
Yeah.
So I have a kind of different perspective on this. Like, I don't actually really like how natural language is so irregular. So one of the languages I'm creating is called Kaiden. I think I talked to you about it a lot before. Yeah, I did, right? Yeah. That language, I'm trying to create it in such a way that it is so unambiguous and so easy to parse that you could literally write a classical AI to parse the sentences in that language, and it would be like there would be like a one-to-one understanding between like human actors and like the AIs itself. So I'm sort of working backwards compared to most
See,
people, I
my
guess.
thought with that is it purely written or is it spoken as well?
Oh, it's both. Yeah, I want it
So,
to be.
how do
Yeah.
you factor in body language and intonation?
Oh, well, like there shouldn't be any body language or intonation that is like necessary to communicate meaning. Like, I mean, English, I mean, I think all major languages are like such that you could still communicate everything you need if you only had writing. Um, so, I mean, I don't know how to create a speech to text engine for it just yet because like the solutions I've found are like not really very easy to implement. So right now, like the language is essentially just text because, like yeah, but I am designing it with the intention that people should be able to speak it in some far off
Mm.
future.
So, your goal would be something like saying hi or hi. Would essentially be the same thing. Like, whatever way someone would say it, it would still mean the same thing.
Well, I mean, like, what do you think when someone types like HI and then period and then sends it to you? Like,
See, there's like information that I wouldn't get, but in person,
mm,
there's much more information someone convey beyond just a simple word. And
right,
that's
right.
the
I
harder
mean,
part to capture.
mhm. I'm not really like thinking I could even get to a point where I would create like a humanoid robot that speaks Kaidan where they would need to read body language at that point. I'm still just trying to just solve the problem of like
Mm.
creating like a language that is mutually understood by like AI and human beings that is just text based. But like if in some far off future I end up making a
Uh.
humanoid robot, I guess I'll consider body
Oh,
language.
okay. So I guess my understanding is a little off. So it's specifically just of human to AI. It's not going to be human.
Well, it should be human to human too. Like I'm trying to create something where I can like make a number of applications like viable for it. Like for example, like uh this sounds like rather contrived, but I always wanted to create a video game where you can like kind of talk to the characters inside. Either like, you should be able to like let's say it's a competitive shooter and you want to make call outs that are understood by your AI controlled teammates or something like that. That would be like a case where like you don't really need like any kind of emotional statements or anything because you're just either stating facts like oh they're like 2 and B or you're like asking questions like do you have an op or something or you're giving an order, right? Like cover me or something. But then eventually I want to get to a point where I could even create like a more like life simi kind of game where you can like talk about more emotional things or something. I don't know.
I was gonna say that
And then
sounds like you should go into VR.
oh yeah, if I can get something that will look convincing, then I'll definitely go into VR. But right now, I don't really know how to make humanoid animation look good, so I'm sort of just considering just the communication part. But if at some point in the future I manage to create a humanoid locomotion system that like looks believable, and I have a bunch of like high quality models and like high quality like meshes for an environment like a city or something, then yeah, sure, I'll like go into VR. But
Just
at
say,
this point, like I'm still working with like squares and shapes.
yeah, I've seen some of your games. Like,
Yeah, because I don't have any money, bro.
I get you. I was gonna say you should work for Valve because did you see their announcement for the new Half-Life game? The most
Yeah, Half-Life
realistic,
Alex.
yeah, the most realistic virtual reality game I've ever seen.
It does look pretty realistic. It also looks like they managed to figure out a lot of ways to make VR like a little bit less annoying. Like they had that thing where if you point at an object and then press some button, like a little orange energy beam comes out and like attracts it to your hand
Yeah,
until you finally grab it. You remember that part, right?
I
Where he
saw
grabs the pistol like that?
hmm
That was kind of cute. But yeah, I guess time will tell if that game will sail or not because like it has been like over like 7-8 years since Valve has like made an actual video game. So who knows how they are, like if they're like still good at that at this point. I mean, they still have like a large amount of expectations, considering this is like another installment of a Half-Life game, and people have been waiting for Half-Life 3 for like decades now.
Even longer than
So,
Kingdom Hearts.
yeah, that's right, even longer than Kingdom Hearts. So time will tell if that would be like a fluke or not.
So, something interesting that I saw recently. I was
Yeah.
looking at the job listings for Arkham, for a new Arkham game that's coming out, I think, next year. It's
Okay.
by Warner Brothers Studios. And I was looking at the requirements for being in the job, like getting the job. And aside from the art stuff, which is obviously using art programs and stuff, a lot of the coding for the engine was through C and C++, like having 3 to 5 years of experience. So, what do you need to actually build a video game? Like, because I've heard there are game engines you can just straight up use, but what if you're trying to go from scratch? What do you need to do?
Oh, from scratch. That's really hard. But I guess what you would need to do is first like figure out what platform you were doing it for, because like if you're coding something without a game engine, it'll be pretty platform specific. So that means like, is it Mac, Linux, or PC? Is it like PS3 or Xbox? Is it like Wii U, whatever? And then for if it's like a console, generally consoles won't have like a way to code like games for it from scratch. Like you will probably have to use an engine. And I get like I have a feeling that like Batman Arkham City uses an engine, probably like Unreal or something, which is a game engine that uses C sharp. I mean C++. I use Unity a lot because it's pretty easy. Unity is like a C sharp engine. But yeah, if you were doing something for Mac and PC, you could definitely do it like from scratch. What you would have to do is like determine if it was like 2D or 3D first, and then if it's 2D or 3D, that'll change how you code the camera, which is like the thing that renders like all the playable characters and stuff into the world so that you can see it on your screen. So if you're doing a 2D camera, it's a lot easier than a 3D camera and stuff like that. And then you'll have to code like a way to start making geometry. Like you'll have to code like how to make shapes if it's a 3D game, like triangles and vertices into like actual objects, and you have to like code a shader that tells the computer how to like shade the part of it closer to the light brighter than it is than the part farther from the light. Of course, this is again easier if you're making a 2D game, because you'll just have to display the sprite on the screen, and unless you're doing any special effects, that's pretty much all you have to do. And then from there, like you just have to keep going. Like you have to code the input system. Like if a player presses Q, like what happens? So you have to like code a bunch of callbacks that will like take player input and then expose themselves to other parts of the code base, so that you could say like, if input manager dot get button down Q, like do something that you want to happen when the user presses Q and stuff like that. So most people don't really code from scratch, just because there's so much stuff that like people don't really want to do, because it takes forever and it's very easy to get stuck. So like my general advice would be to start with Unity, just because it's like the easiest of the 3D game engines. But if you want to start, if you want 2D games, like you can always start with something like GameMaker, just like the program that was used to make Hotline Miami. GameMaker has like a freemium version that's not super good in my opinion, but like it's pretty good at like teaching game dev fundamentals. So then you can start there. But then if you want to get something like different, there's a game engine for every purpose, right? There's like Unreal game engine. Unreal is like definitely one of the most beautiful game engines out there, because it just like has so many shaders out of the box that are really good. It has like a lot of support for like just like a lot of like high quality things, but it's also like C++, which means it's a compiled language. So every time you want to like play test your game, you have to like wait for like 1 to 5 minutes for the entire game to compile, and then you can like play test it. Whereas game engines like Unity are C++, which is C sharp, which is like slightly interpreted. So as soon as you press the play button, you can start exploring. There's like a whole bunch of stuff that you could do in this field.
So what engines have you used, Hakan?
I use like GameMaker, Unity, Godot, which is like one of the Godot is like a uh, open source 3D game engine. I just like tried it out a little bit because I like to support the open source community. Although Godot at the time that I used it didn't have very much functionality, so I just kind of like moved on. I use Unreal as I said before, but like I was kind of fed up by the like having to wait all the time to play test, especially because I wasn't really sure what I wanted in like the games I made with it. So it was like it really stunted my development cycle. Um, and yeah, I made things in GameMaker too when I was like a little younger, and then uh, recently I've been making things in a game engine called Phaser. Phaser JS is like a game engine for the browser. Like it's a JavaScript game
Yeah,
engine.
didn't you make like a soccer game or what was it on it? You made a game on the browser recently.
Oh yeah, so my soccer game I made in Unity and I exported to WebGL, which is another thing that's nice about Unity. You can export to like pretty much every platform. But Unity like unfortunately isn't really a very lightweight framework, and so when you export things to WebGL, like it'll take you about like 2 minutes, maybe 1.5 if you're lucky, to load the game as soon as you like go to the website because it's like a pretty heavy engine. Whereas Phaser will load immediately because it's JavaScript.
So what projects do you have on the line right now? Any game development kind of stuff?
Okay, so right now, as we very speak, I actually am trying to figure out how to like take this project that I've been working on for a very long time and kind of split it up into more bite-sized pieces that I can finish earlier so that I can give myself more motivation. Essentially, I've been working on a first-person shooter that's like very similar to Battlefield, but because like the primary goal of that game was to make a FPS game where I could make AI for it really easily. So I kind of like changed the game mechanics a lot to suit what I knew I could code AI to do. Like for example, it's really easy to create AI that's very good at pathfinding because like the way AI does pathfinding is it uses something called Dijkstra's algorithm, which is like yeah, Dijkstra's algorithm is like an NP complete algorithm for finding the very fastest route from 2 points between 2 points in like in a network. And so like I've been purposely creating fairly complicated maps where like one thing the player has to be good at is finding the fastest route between two places, because then it like kind of makes the AI like relatively good with respect to the player because they're really good at that. And like another thing is like I'm creating a game where, you know, like in Battlefield, I don't know if you remember in Battlefield you can like give like med packs and like ammo packs to your squad mates, and there's like things that you can do to hurt the enemy, like shooting them, and there's things that you can do to help your teammates like in a very direct way, like giving them health or ammo, or reviving them, or putting down a spawn beacon or a motion beacon or something like that. So I'm creating like 5 classes where they each have a thing that's easy for them to do to help their teammates, because then that's like, you know, like AI is also very good at multitasking because you can give AI like a list of things that are like of varying priority and just say like just execute these things in order, or just like depending on the situation execute the thing that's like the highest priority. And so like, you know, let's say it's walking somewhere, and then among the things to do when there's no enemies around is like put down like a speed beacon or something that makes your teammates faster or something like that. But then all of a sudden it sees someone, and so the highest priority thing is to shoot them until they die. And then so the AI like shoots the enemy until the enemy dies. And then it goes back to like the previous situation and it tries finding what's the next like highest priority thing to do. So like, you know, human beings have a tendency to get caught up like with tunnel vision on like a single task if they're under stress. You know, like generally people who like play games like Battlefield, there's like a phenomenon where people will like start corridor shooting, and that's where like a bunch of people get caught up on one corridor of the map, just like shooting down the corridor and like reviving their friends who die at it instead of like flanking around and killing the people from the side, because like they get so caught up on that one corridor and trying to push through it that they just keep going at it. Is something you like see a lot in games. It's just like due to human beings like like inability to like not get emotionally invested in things that they like try really hard at, essentially. And like AI has no problem like switching tasks if it all of a sudden becomes more expedient to do like A versus doing B. So like I'm trying to like design a game that like is in such a manner that AI can be good at it in all those ways, and like that way I can make a game where like even if there's nobody online playing, you can still have fun. Because I remember like I tried making a lot of multiplayer games in the past, and like if people just weren't playing, like it wasn't fun because there's no one on the server. So I knew I needed to make something with like competent AI so you could still like have fun by yourself.
No,
So that's what I'm working on right now.
there's an AI tree. It's not for a multiplayer game. It's for a single player game that I think you would be very interested in learning about.
Oh,
You know, Alien Isolation.
yeah,
Oh,
yeah,
nice.
yeah. I know that game.
Yeah, the AI in that game is very interesting because it has two major trees for commands. And the first one would be like it's what it directly sees around it and how it interacts with the world that it has a view of. And that includes like, for example, let's say you're in the same room with it and you're hiding. It makes a decision whether or not to check that spot where you're hiding. Like, or it could check the one right next to, like, if there's a bunch of lockers and you're in one of them and it can see you go in, it's subconscious. It makes a decision of which locker to open or check any at all, or to check multiple of them, and stuff like that. But the cool part about it is that there is this kind of master code behind it, which gets progressively gets more pathways unlocked as you go through the game. And the whole purpose of that is to make the alien as present as possible. Whereas if you haven't seen him in a while, it will just tell it where you are. Not exactly where, but the room and like the general direction of where to go be. And, to keep harassing you with things like that, and to try to fake you out. Like it'll hiss to try to get you to move, and it has a feeling that you're there, but it hasn't seen you directly, and stuff like that. Or it'll fake you out by going up into the vents and then coming straight back down, because when it's up in the vents, it can't hear you moving down on the ground. So that's earlier in the game, you're trained to when you hear it go up, you're safe. So later it'll start faking you out with stuff like that.
Oh my god, that's scary.
I know. And
that's like
it's a very complicated tree, and I think you would like to learn more like about how that one works.
Sure, dude, I'll take a look.
Okay, so let's go into game design. How do you go about training the player to understand the world which you have built for them?
So there's a lot of different philosophies, but the one I subscribe to the most is just creating like an interactive tutorial. You could always, I mean, in the very beginning, what people would do is just like make a very big instruction manual and like ship it with every copy of the game and just hope that people read it. And if you ever gotten a game from the 90s, like you never read that, right? Like
I used to actually, because they had cool stuff in them.
Oh, okay, that's great. I actually used to as well, but most people I've talked to like have not read those things.
What, the little pamphlets in the case?
Yeah, the little pamphlets,
Of course you read them.
You read them too?
Cool art.
Yeah.
Oh wow, okay. So everyone in this room has actually read them, but the friends I've made in who have like, you know, like gotten things of that nature have not read them, and we're like, oh, it's just a waste of paper.
Yeah, it makes me sad that they're gone now, because these used to come with like more lore for the game and like more art assets that you wouldn't see otherwise. And these would be so
That's
cool.
true. That's true. They did come with lore, which was I think one of the nicest parts of that stuff. I would say like it's a little sad, but I can kind of understand why they got rid of them to some degree just because it was like a lot of paper.
Mm-hmm.
And they were trying to reduce that, which is understandable.
Reduce costs
But like,
too, because then you have to print it out, make the assets for it, instead you can just make a text document with all the information and just have
yeah,
it,
exactly,
on it digitally, like you see on the DS and Switch.
And yeah, I mean now like when a game gets big enough, like the YouTube tutorials for it are so good that sometimes they're even better than the in-game tutorials and stuff.
Oh, that's
But
cool.
yeah, essentially, what I would say though is like I like to try to create something where like a tutorial level where like things are spread out from the player in such a way that they can kind of like slowly learn the ropes, and then there might be a few like hints in the environment that teach them how to do things, but altogether like they probably, you want the player to feel like they figured it out on their own. And so like one example of how you can do this is like in a platformer where you like move to the right, you can like start the very first level with like a very simple obstacle, and then perhaps like a sign with like the button that you want them to press to jump with.
Mhm.
And then you like, the player usually will figure out, okay, I press this and then I jump. You know, there's always like there's always like a sort of like reliance on the fact that you're making a game for a certain audience on this, because like there are some audiences that just like want to be told what to do. For example,
And
like
then there's
my
the complete opposite, like me, where I hate it when the game tells me what to do. When they give you the tools, and you have to figure out how to best apply them.
Rust!
You have all the puzzles to. You have all the puzzles for the. You have all the pieces for the puzzle. It's just up to you to piece them together, and then you get a harder puzzle when you still have the same tools, but you still have to keep going. And like you have that progression, and it feels the best when all the tools they've introduced you across the game are integrated more and more, till at the end you have to rely on everything you've built upon to be able to succeed. Like that feels the best when you're, in my experience playing a game. I hate it when they just give you the answer, give you whatever it is, just to make it easier for you.
Yeah, I agree. And my roommate shouts Rust because Rust is an example of a game where you definitely don't have any hand holding. You've heard of Rust, right?
I don't know the Rust you're talking about, but because there's a shooter Rust that I know and we've talked about before.
Oh, Rust 314?
Yeah.
Oh, that's Dust.
Dust. Oh, okay. I don't know Rust.
Yeah. Oh, Rust is also a shooter technically. It's like a. All right. Well, let's let you want to explain Rust, Ian?
What?
You wanna-
I want to explain Rust Lord of the Flies simulator. If Lord of the Flies was 90% your redneck basement dweller video gamer.
Yeah, I mean that is
How
kind of
the
true.
game works is you spawn on a beach naked with absolutely nothing, and yeah.
Oh, that game. Okay, I know that game now. Yeah.
Oh,
Yeah.
okay. You've probably seen it in like YouTube Let's Plays because
I've
like
seen
it's
YouTube's Let's Players do that.
it's home to a lot of degenerate shit. Just because like when you put people in a situation where there's like not, you know,
Lord of the Flies.
yeah, it becomes Lord of the Flies. Like for better or worse, it's kind of interesting. But yeah, like a lot of multiplayer games don't hold your hand because they just kind of expect you to figure it out by playing. Like Counter-Strike is the oldest example, I would say, just because like you start, you know, there's like no tutorial in Counter-Strike, at least like until the latest installment, Counter-Strike Global Offensive. But you know, there was no tutorial in Source or anything on how to do any of the advanced maneuvers. You would just get on a server and just get continually wrecked by people until someone like taught you how to do something, or you figured it out on your own, and then that was when you like learned. And so like, you know, ever since people started making tutorials for things on YouTube, like I feel like a lot of game developers of multiplayer games kind of gave up on the idea of like making a profound tutorial, with a few exceptions. I mean, there's like Apex Legends, which has a pretty decent tutorial. Counter-Strike has a tutorial now. It's not like the best tutorial. I guess it's like okay-ish. And then I don't know if does League have a tutorial? League did have a tutorial, right?
League?
What did I do? I did a tutorial,
they
right?
have a tutorial.
Okay, yeah, they had a
lengthy
tutorial.
one too, actually.
Say again?
pretty lengthy one too, actually.
Oh yeah, that's right. It did take a while. I don't know if Dota has a tutorial though, right? I think Dota doesn't, and Escape from Tarkov doesn't. Rainbow Six Siege does, I think. I guess.
Tutorials are a fairly new thing, I think, because before, at least early gaming, like arcades and NES stuff, there would be a demo of like how the game runs.
I mean, I feel like tutorials were around since the early 2000s.
But I think like a lot of like arcade games didn't really want tutorials just because they wanted you to not win so that you could pay more money. There was definitely like a incentive for arcade cabinets to make money, and so like having like a ridiculously hard final boss was sort of like a common design pattern and stuff like that.
And also, game design, I feel like, has changed since then. Because in early games, a lot of it is there's a specific pattern that as long as you can understand and predict the pattern, you can do well, go level after level. Whereas, I feel like that has more changed. You go interact with the world and figure out how the world works. There's more variation in it.
I mean, it's partially due to there being stronger computer hardware to support like a fairly complex world, whereas like, you know, I guess a good example would be Street Fighter. Like early Street Fighter games were pretty simple, at least in terms of like Street Fighter 2, where like everyone had like a pretty constricted meta, because it was just like there wasn't very many things you could do. It was always like sort of like more advanced plays of like faking out, but you could always do that in any fighting game. And then since then, like Street Fighter has gotten like loads more complicated with like all these different characters. Now there's tons more matchups. There's tons of like new moves, and even then Street Fighter is considered one of the more easy like fighting games to pick up. And then you can like get even more hard with like Killer Instinct and like Tekken and like all the way up to Virtua Fighter. Smash, of course, being a different kind of fighting game, like it's not really the same sort of skill ceiling because you're not really counting frames in Smash, but instead Smash is a lot more about positioning, I would say. And you know, that's which is good, right? It's like a completely different kind of game design.
It is nice. And I guess for Smash specifically, I prefer seeing the varieties of movement that you can do, which I would say are more restrictive than other fighting games.
Yeah, I agree, and I think like part of the reason why it works in Smash is also because like it's like Smash's directional attacks is sort of like meshes well with its movement, because in order to like hit someone with a down air, you have to go and jump over them and stuff like that. Whereas in like Street Fighter, like moves will have like the movement in them, like
oh yeah, like Hado, like the Ryu's
like
side special.
Oh, Tatsumaki.
Yeah, he spins a circle and moves across the screen.
Right, and like the reason behind that is also because like making the choice of that move is not just like if you want to hit someone with that move, but it could also be like you wanted to get close to this enemy really fast, so you Tatsumaki instead of sprinted or something like that. Because like in Street Fighter, like moves are sort of like the way to move around, kind of. Whereas like in Smash, like it's more often that you would like physically move your character in range of a certain attack and then use that attack.
And also you throw attacks to keep them away from you and let you go in. Like you can't space them out with these hitboxes, which you throw out. So we're over an hour, and I know we keep talking for like for a while. So let's finish off by playing your stuff. So you're Kimeiga and Hakan.
Oh, okay. Okay.
You have Mappening, right?
Yeah. So I mean, we changed the name to B-Maps because of did I tell you about like the legal? Yeah.
Just remembering now.
Yeah, sad times, but yeah, we're bmaps.io. I mean, bmaps is not really an easy thing to plug because unless you live in like Westwood or UCLA, it's not really useful because we didn't expand to other schools. But yeah, it's like an event discovery app.
Check out his games and his blog. You have two of them now, don't you?
Yeah, now I have two blogs because I was really like, uh, I like really wanted to blog from my phone, like because I like to. Sometimes I have ideas and I have my phone and I'm just like bored. Like I don't want to, My other blog I built from scratch with a static site generator called Jekyll. So to add to that blog, I have to literally like go in the code project and like add new files and like kind of add new markdown, find new like images and stuff, and then like make commits to GitHub, and then it'll like appear on my page. And then I was like, what if I want to blog for my phone? And so I looked at all the different blog services that had an app, and by far like the best app experience was Blogspot, the one that was just owned by Google for forever now. And Blogspot happened to come up with like a lot of really nice themes out of nowhere. Like I don't even know like who still uses Blogspot, but whoever does, like they could switch at any moment to like I'd say like 11 or 12 of the new themes they added are actually really nice. So I just found one of those themes. I downloaded the app and then I just started like saying random musings on Blogspot from my phone, and it felt really good. So yeah, I'm also on Blogspot now. Superhockey.com.blogspot.com.
Okay, cool. Well, thank you for coming on. It was a really good discussion.
Dude, of course. Anytime.
All right. Well, so everyone out there, have a good one.